Sound waves are longitudinal waves. This means that the disturbance is parallel to the direction that the pulse or the wave is moving. The disturbance is what caused the pulse or the wave in the first place. Remember, a wave is just lots of pulses, one after the other. This is a single longitudinal pulse caused by a single disturbance. It is moving through the medium towards the right. The best way to observe longitudinal waves is to do so on a spring. But remember, the waves behave the same in other mediums, even though we cannot actually watch them and see what happens. The waves have areas of compression, which are the pulses, and areas of rarefaction, where the medium is spread out between the pulses. The wavelength is the distance between two consecutive compressions or two consecutive rarefactions. Wavelength can be measured if you can see the wave, like in a spring. We can measure from the beginning of one compression to the next, or from the end of one compression to the next, or from the middle of one compression to the middle of the next one, or from the middle of one rarefaction to the next rarefaction. Amplitude is the maximum distance that a particle moved from its place of rest as the wave moves through the medium. Keep an eye on the orange piece of spring. As the pulse moved from left to right, the orange piece of string was displaced, as shown. This is the maximum distance it moved, and this is the amplitude of the wave. Period is the time taken for a single wave to move past a single reference point. In other words, from the beginning of one wave to the beginning of another wave. If we watched the spring with the wave moving through it, and we timed the time it took for the wave to move one wavelength, we would get the period. The frequency of a wave is a measure of how many waves will pass past a reference point in 1 second. 1, 2. The frequency of this wave is therefore 2 waves per second, or 2 Hertz. While it is difficult to measure the wavelength and the period of a sound wave, we can measure the frequency. We also know the velocity at which sound moves in various media, and we can use these equations to calculate the period and the wavelength of a particular sound wave. An earthquake occurs far underground. The wavelength of the resulting shock wave is 100 meters. The shock wave moves through the Earth's crust at 6,800 meters per second. What is the frequency of the wave? And what is the period of the wave? Start by writing down the given information on the right-hand side. This formula contains all the variables we have written down, and therefore we will use it to calculate frequency. Substitute the values and solve. Now that we know the frequency, we can calculate the period using this equation. Substitute the values and solve.